I'm going to start off by saying, okay, so the idea is there's data, and from the data, I want to make a model that can help me with prediction and so on. So the first thing I want to introduce is whenever we see data, there's going to be some noise in the data. And so I'm going to start with a discussion of randomness, okay? Noise or randomness. And so it's a very interesting question. So I want to ask this question. Start thinking about what is the meaning of randomness. What is randomness, right? We talk about it in language. We think we understand it. But now I'm going to ask the question, can anyone give me a definition for randomness? Somebody want to try? Suppose I gave you a sequence of numbers and I say, can you check if this is random? What would you do?
Random being its numbers are not being repetitive. Let's say you flipping a coin, and if it is not sequentially coming heads all the time, or you have a range from 1 to 10 and you ask him to produce a number from 1 to 10 and same number is not being produced over and over.
Yeah, that's a test, but I will say, suppose I get, 9 heads and 1 tail. Is this random or not?
You can still say it's random.
Yeah, but now we don't know, right? Or for example, suppose I wrote a program that says print out 9 heads and 1 tail, and then 9 heads and 1 tail. That's completely deterministic, isn't it?
Yep.
If I encoded a pattern, we would not call that random. Once I show you this program, you would not call this random anymore, right?
Okay, yep.
So what am I challenging this discussion with is by saying, okay, in order to understand what is random, you can come up with many tests, right? So you can say, no, the pattern should not repeat, but then we have to start searching for patterns. And at the end of the day, the result is very complicated, right? It says the absence of all possible patterns. And that's not checkable easily, right? So there's a whole subfield in computer science of being able to test if a sequence is random, okay, which we won't get into today. But what is interesting is as humans, we think we know what randomness is, but actually we humans are pretty bad at coming up with tests, identifying randomness. And if I ask you to write a random sequence and compare a random sequence that you write with a real random sequence that is generated from some, I'll show you in a minute, there are no real random sequences around. But if you compare it, you can do this experiment at home, right? You can take a coin and flip it like 50 times and just write down what you get. And then try to write down a sequence of 50 heads and tails by yourself and try to see what's the difference between the two sequences. It turns out that the human generated sequences are not very random either. But that's a bigger discussion. So let's go ahead quickly and say, now I'm going to say, okay, suppose we want to write a program. So first I ask the question, how can we check if it's random? Now I'm going to say, is it easy to write a program? If I tell you write a program to generate a random sequence, can you write this program?
Using random, it can be done.
So what is random? How does random work? Is random rand? Is rand? So there's a, I spent.
No, in one of the previous discussions, you had told that even random is kind of programmed.
Yeah, and okay, there's a logic. Okay, so anyway, let's take this quiz and see what happens. Everyone can submit something. Let's see. So what is it? Okay, so let me explain this. It's logically, it's very easy to solve this problem, right? What is easy is that if there was a program to generate random numbers, it is a program after all, isn't it? And that program is deterministic. How can you write something inside? The program is fixed. So the program itself is not random. Therefore, what it generates is not random. You see what I mean? To generate something random, the thing that generates random stuff must also be random. A deterministic thing cannot generate a random thing. Again, for Cassandra, maybe I will ask you, does this sound like one of those philosophers' conundrums?
Yes, definitely. And on a more practical level, I know sometimes I'm trying to do something for my class and I know Excel spreadsheet.
Yeah.
The function that allows me to assign random numbers to students, but I don't think that's really random.
Okay, so yeah, but I'm saying there's interesting philosophical questions, very deep questions. Where does randomness come from, right? Because all our human efforts to write a program to check for randomness, etc., seem to come short. So what is truly random? Where does it come from? is interesting. And it's a big discussion. In physics also, there are very interesting discussions about where does randomness originate from. But we won't get into the technicality right now, but I will take away a few things. One is you need extra power to even try to test if something is random. You need a lot of thinking. And now you need more thinking to figure out if if you write a particular program to generate stuff, that program will not be generating real random numbers. These programs that we have in Python, and we're going to use some of these programs soon, will actually generate what are called pseudo-random numbers. And pseudo-random number is something which has many properties of random numbers, but it's generated by a program. And so it's almost random, but not random, right? A good example of this is one of the things that looks very random is the digits of, if you take pi is a number, but the digits of pi, you can compute up to 1 million digits of pi, right? In fact, I've given you a series assignment last time to compute the digits of pi. We can take the digits of pi and say, hey, that's a bunch of numbers, 3.1415, blah, blah, blah. That seems like random integers, right? And so we can generate a random number generator by just picking the digits of pi. You don't have to start from the first digit. You can start from the millionth digit, or you can just sample the digits of pi. It looks very random. But the moment I tell you these are digits of pi, then the randomness is gone, right? So you see, that's the pseudo-random nature, right? Whatever mechanism I use to generate what looks random, as soon as I tell you a program or how I generate it, then the randomness is gone.